Recursion is all around us. Kaleidoscopes, snail shells, snowflakes, and ferns all follow recursive patterns, but it can also be an important programming technique to solve problems like sorting. I have the official definition of recursion here on top in a comment, but in practical terms, a recursive function is a function that will call itself repeatedly until a base case is satisfied. Now, you might be wondering if it's possible to use a loop instead of using recursion, and the answer is yes. A lot of times when you are programming or coding, there are more than one solution to a given problem. The reason you would use recursion in certain situations is a recursive solution is just more natural than an iterative solution in certain cases. Two famous examples are quicksort and tree traversals, and I will leave links to articles about those in the description. There's a well-known Easter egg in Google. If you search for recursion, it says, "Did you mean recursion?" And if you click this, it'll just keep showing up infinitely. So just a little Easter egg there from Google. To illustrate recursion practically, I have written a function to find the factorial of any given number, and it is found recursively. So this function takes in n, which is a number, and if n is less than or equal to 1, it returns 1. So if it's 1, it's 0, it's just going to return 1. Otherwise, it's going to return n times factorial n minus 1. So if you want to think about this as an example, 5 factorial really is 5 times 4 factorial. And then 4 factorial is just 4 times 3 factorial, and so on until you hit the base case. So let's go ahead and run this. And yes, we get 120, and 120 is 5 factorial. So from here, we're going to go ahead and solve another Project Euler problem using recursion. So this problem says each new term in the Fibonacci sequence is generated by adding the 2 previous terms. By starting with 1 and 2, the first 10 terms will be by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even-valued terms. So we're back in Visual Studio's code, and I have written the problem here in a comment, and I'm going to just give you a chance to first solve this problem on your own. So go ahead and try to solve this, pause it, and keep in mind this is a video about recursion, so your solution will likely be a recursive solution. Okay, we are back. So first thing we're going to do is we're going to have var total equals 0. And at the end of our solution, total will just be added all the terms and then will just be returned to us. We're going to just return it in a console.log, and then we will enter it into Project Euler and see if that is the solution. So we're going to have a recursive function here that just generates Fibonacci terms. So we're going to call it function, and I'm just going to call it fib. And the reason for this is I know that in some math libraries, there's already a function called Fibonacci, but we want to just make our own. So this is just going to be function fib. So this takes in 2 numbers, which are the previous 2 terms, and it will add them together to find the next term in the Fibonacci sequence. From here, we're going to find our sum. So that's just going to be var sum equals x plus y. And we know that if sum exceeds 4 million, we're done, because it's like we only care about the terms that are less than 4 million. So we're going to say if sum is greater than 4 million, return, because our work will just be done at that point. Now we're going to test to see if it's even, and if it is, we're going to add that to total. So if sum mod 2 is equal to 0, total equals total plus sum. If you don't know what mod is, I covered it in a previous video when I talked about the mathematical operations in JavaScript. But basically what happens is the number on the left is divided by the number on the right of the mod. So the percent sign is the modulus symbol in JavaScript. And then the remainder is returned. So if a number mod 2 returns 0, you know that number is even. And then at the end here, we have to recursively call fib. So we're going to say fib, and then, so when we're doing this, x is going to be our smaller term and y is going to be our larger term. So on the next iteration, y is actually going to be the smaller term. So we're going to say y, comma, and then the other term is going to actually be the sum. So sum becomes y in our next run through. So now we're just going to run our function here. So we'll just do fib, and we're going to do 1, 2, because those are the first two terms of the Fibonacci sequence. And this will just run recursively until it hits 4 million. And each time it will add to total if it's supposed to, and then we can print out total. But there is an issue with this code. There is actually a little bug. So if you want to go ahead and pause the video, you can try to figure out for yourself. Yeah, so the bug with this is the first time we run this Fibonacci function, x will be 1 and y will be 2. So the sum is going to be 3. But this will just completely bypass 2, which is an even term under 4 million. So it should be added to our final total, but it's just going to be skipped. Now, there's a couple ways we can solve this. One is to just start our solution here as 1, 1, and this is all right. But the problem I have with this is in our definition given by Project Euler, it says it starts with like 1, 2. So like if you're starting with 1, 1, it's not really in the same spirit of what Project Euler gave us. So what we can do instead is set our total to 2. And either way, this will give us the correct solution here. So I'm going to go ahead and run this. And yes, we get 4,613,732. So we're going to just bring this over to Project Euler and see if this is the solution. So we're back here in projecteuler.info. We're going to put in our solution and then just enter this code to make sure we're not a robot. And let's check it. And yes, so this is correct. So we were able to solve this problem using recursion. And that's pretty much all I have today as far as talking about recursion. If you have any questions about recursion, if you got stuck at all, you can just leave that in the comments, as well as any ideas for future lessons. Please click like. It's totally free, and have a great day. And thank you.